Hello and welcome. Let's implement process and thread, both things in the Python. So we implement thread by the help of threading module, and the threading module have a thread function in by which we can make the thread. And we have to call target. By the help of that, we will like give a particular target or the function that we want to execute in that particular thread. So what thread do? Thread execute something, so we have to pass that in the target variable. Okay, so let's come here. So we have to import the threading first. Once the threading module is imported, we will make a function that we want to call as the target. Okay, so let's say our function is print number, where this we are getting the current thread by just to print its name and ident. Okay, so we are running a loop here, and we are saying like my thread id is this and my name is thread.name. Okay, then we have to like make like implement the main function, and there we will make two threads. So the main function, we are making thread object by calling threading.thread, and in the target we are passing the function that we have because we want to run this print number inside our thread. And let's name the thread as my thread, and we will call the second thread also. We will make the second thread also, and we'll call it my second thread. Then we have to start both of the thread, and we have to make like kind of a blocking threads. Once the execution of both is done, we will then end the program. So we will start both thread, and we will like wait for both of the thread to be completed, and that is done with the help of join method. So what do join do? Join basically wait until the thread terminates. This blocks the calling thread until the thread whose join method is called terminates. Okay, and after these things the main will be terminated. And then add this, like if my name is main, then let's like to execute the main function. When main will be executed, it will make two threads, both will be calling this print number function, and eventually the main will also be terminated once both threads are terminated. So to run it, let's call python3. The name of my file is thread versus process.py. So as you can see here, we have two thread. One is thread name is my thread, so this is one thread and this is another thread. Because we are running it 5 times, the same things are getting printed multiple times, and in the end the main execution was wrapped. So this is how you implement two thread, or you can implement multiple thread in the Python. This is one way. There are other ways also, but the goal is to tell you about basic of like how we do implement threading. So this is one thing. Now let's talk about how to implement process in Python. Now we have to implement process, and the process is implementing by the help of multiprocessing module. So first import the multiprocessing. A multiprocessing module provides like process method to make the processing. So this is our function that we want to run in multiple processes. Okay, here we are like again calling the current process like we did with the current thread. And then this is our main function. Here we are starting to process by multiprocessing dot process and giving the target as the function. You can see the interface is kind of same. We are starting to process, then we are waiting for them to be completed, and then in the end we'll call the main. So let's do it like let's run it. So here you can see we have like process id, the two processes are running, and once they are done we are like ending the execution. Now let's talk about how these two threads are running, the behavior of these threads. Okay, so as we have seen already that we are having two threads, thread 1 and thread 2. They are in this function print number. So let's import time here, and we will add a slip here. So that is time dot slip, and let's slip it for 5 seconds. So now we are adding a gap of 5 seconds for both thread. Okay, and now let's run this program. So you can see the interleaved execution of the threads will come. Yeah, so when we add time.slip here, so you can see that first this thread is running, then the second thread that came, then the first thread, like that. So at one time only one thread is running, but they are leaving interleaved, so kind of concurrency is there, but at one time one thread is running. This is important. And why it is important? It's because Python have GIL. The GIL is global interpreter lock. So Python is not thread safe, and it is thread safe by the help of GIL. So GIL ensures that if one thread is running at one time, another thread can't run. And why so? Because Python want to ensure that the object from the memory are not taken by two threads at the same time, and to have some memory leakage issue or to have some race condition. The point is, two threads can't run at same time, and this is what is ensured by the GIL, because two thread can't run at the same time. Even though you are having multi-core CPU, your Python will only run on the one thread, or you can say it will only run at a time one thread. Why so? Because as I told, like, Python is not thread safe, and this is like a kind of a controversial topic in the Python community, to release the GIL or to like keep the GIL in the further like in the versions. Actually, the implementation of GIL was changed in Python 3.2, and a set timeout was added, but we will not go into that much detail. But the idea is, like, a GIL is a mutex that ensures that only one thread is running at a time. Now let's talk about how these two threads are running, the behavior of these threads. Okay, so as we have seen already that we are having two threads, thread 1 and thread 2. They are in this function print number. So let's import time here, and we'll add a slip here. So when we add time.slip here, so you can see that first this thread is running, then the second thread that came, then the first thread, like that. So at one time only one thread is running, but they are living interleaved, so kind of concurrency is there, but at one time one thread is running. This is important. And why it is important? It's because Python have GIL. The GIL is global interpreter lock. So Python is not thread safe, and it is thread safe by the help of GIL. So GIL ensures that if one thread is running at one time, another thread can't run. And why so? Python want to ensure that the object from the memory are not taken by two threads at the same time, and to have some memory leakage issue or to have some race condition. The point is, two threads can't run at same time, and this is what is ensured by the GIL, because two thread can't run at the same time. Even though you are having multi-core CPU, your Python will only run on the one thread, or you can say it will only run at a time one thread. Why so? Because as I told, like, Python is not thread safe, and this is like a kind of a controversial topic in the Python community, to release the GIL or to like keep the GIL in the further like in the versions. Actually, the implementation of GIL was changed in Python 3.2, and a set timeout was added, but we will not go into that much detail. But the idea is, like, a GIL is a mutex that ensures that only one thread is running at a time. And let's see about this with the help of a diagram. So this is necessary because Python memory management is not thread safe, and we will look into what is memory management, how it works in Python in detail. So how it happens is, let's say one thread is running. This is your one thread. If it is running, then and if you have to like do some IO on this particular T1, okay, then what like, let's say you're doing some API call, so you're going for the API call, and now you want to run thread 2 in this meantime till T1 get the response. So we have to release the GIL and acquire the GIL on the T2, then it will run. Then T2 will do the same thing for the GIL, and then T3 will run, then T3 will do the same thing, like that. So at one time GIL is there ensuring that now T2 can't run. When we go with like like when we are doing some IO bound task for the T1, it have to release the GIL, and GIL will come on the T2. So at one time only one thread can run. Okay, it will not happen that T1 and T2 both are running. It can happen that T1 is running, then T2, then T3, then again T1, like that. So interleaved execution will be there. Question is why we have these type of things, and it is like a kind of problem, because like you can't run multiple threads even though you have two cores, C1 and C2. So this kind of gives performance issue. Python is implemented in such a way that makes it easy, like because we don't have to worry about natively like how the memory is assigned if we have like two threads. So the reason for this is reference counting. So reference counting is like it's an integer that keeps track like how many places a particular object have been referenced. For example, if I have an integer, let's say x, and the value is 10, let's say it is referenced at one place. So if if the x got referenced at another place, will increase the referencing counting. If x has reference at other thing, will increase the reference counting. Now when the reference is gone, will decrease and go to the 0, and once the 0 is there, garbage collector will remove the x from the memory. If two thread runs at the same time, then there can be confusion how the reference counting is like. T1 might be already using x, but T2 can reduce the referencing counting to 0, and garbage collector will will be referencing it and it will give error, correct? So let's say because T2 is also using your x variable, but T2 then like removed, and the reference goes from like 1 to 0, from 1 to 0. Now garbage collector will remove the x, but T1 was still referencing it. T1 did not reduced from 1 to 0, but T2 did. So in the case of multi-thread, if the two thread are running simultaneously, this can happen, and the reference counting will be an issue. So when the reference count reaches 0, no one is referencing the object, and that can be deleted from the memory. Okay, so if T2 deletes the x from the memory and T1 might be already using it, it can be a problem. So we don't allow this to happen. We keep these things separate. If the T2 is running, T1 will not run. So keep the reference counting at the proper level. So when we do the thread switching, we store all the this type of data for T1, and when we go back to the T1, we like take a reference like what was the reference count, what was the register state previously. So these things are there, like we saw in the IPC also, in interprocess communication. So GIL limits the Python thread from executing Python code in parallel, so which limit the performance of multi-threaded program that are CPU bound. Okay, that's it, right? Because if your core requires CPU, so you can do one task at one time, correct? So you can't run the things parallelly. That's why it is bad for the CPU bound task. But for IO bound task, the GIL is not that much of an issue, because you can release the GIL and acquire the GIL. Okay, because as the Python can release the GIL during IO operation. Now we have already seen that there we can run two threads like we did with the threading module. Okay, we did like threading.thread, and then we passed the target, right, equal to this, and we did the same thing with the process also. We did multiprocessing.process, and we passed the target equal to our function. How multiprocess works? How multiprocess works is, then the process will have its own GIL. So each process P1 and P2, they will have its own GIL. Okay, so two processes can run simultaneously. This is by using the OS core over not like by the Python capacity, but because each process have its own GIL, so multi-process allow us to run simultaneously and achieve the parallelism, because each process will have its own GIL and they can run simultaneously. But inside it, only one thread can run. Let's say if we have three threads, but one will run in each individual process, because one thread can acquire GIL at one time. So this is about how threading works inside the Python. Okay, we have seen what is concurrency, we have seen what is parallelism, we have seen what is GIL, we have seen how to implement thread, we have seen how to implement process, we have seen about the difference between thread and process, address spaces, and a lot of things, reference counting, and this mutex. Okay, that is GIL, and the how to like release and overcome it by the help of multi-processing. We have seen the very important concept of IO bound versus CPU bound task. Now it is high time to move on to the asynchronous programming.